Hi everybody, and welcome back to video 2 in chapter 6. And when we left off, we were looking at a company that had only one product and refining that equation a little bit. So here's our equation that we talked about in the earlier slides. Sales can be computed by taking the quantity sold times the selling price per unit. And that gives me Q times P here to get to sales. And then our variable expenses can be similarly calculated by taking our variable expenses per unit and multiplying that times the quantity sold, minus, of course, the fixed expenses. So now, the equation can also be used to show the $200 profit that RBC earns if it sold that one bike more than break even at 400 units. So we take our profit, our sales, minus variable costs, minus fixed expenses, multiply that through times the selling price per unit times the quantity, and the variable cost per unit times the quantity minus the fixed costs. And that comes out $200, which I think you can easily see. All right. It is often useful to express the simple profit equation in terms of unit contribution margin. I call that contribution margin per unit as follows. So the contribution margin per unit is going to be the selling price per unit minus the variable cost per unit, variable expenses per unit. And so there's the easy equation. And we can multiply that through. So if we simplify this equation even further, we're just going to take our per unit profit minus our per unit variable cost. That's going to give you your contribution margin per unit. And then multiply that times your quantity less your fixed expenses. So they've kind of shown you through several slides how to really do this properly. Okay, so let's go do an example here. If we were to sell 401 bikes and make $200 per unit. So if we go down to our equation here is the $500 per unit selling price, the $300 per unit variable cost or expense, and there's your $200. We multiply that times 401 units and then subtract out the 80,000, and again it comes out $200 of operating profit. Okay, next we're going to take a look at the degree of operating leverage at a particular level of sales, and explain how it can be used to predict changes in net operating income. This, I believe, is kind of interesting from the standpoint of how you could use this in the real world. Okay, so we have operating leverage. That's a measure of how sensitive net operating income is to percentage changes in sales. It is a measure at any given level of sales of how a percentage change in sales volume will affect profit. So to calculate that degree of operating leverage, we take the contribution margin and divide it by the net operating income. So in this last example, we had net operating income of $20,000 and we had contribution margin of $100,000. So if we divide $100,000 by $20,000, we get 5. That's our degree of operating leverage, 5. Okay, with an operating leverage of 5, if RBC increases its sales by 10%, net operating income is going to increase by 50%. That's 10% times 5 here. And here's the verification. Here, we've increased our sales by 10%. That's 50 units. And so we ripple that through, and our operating income increased by 50% to $30,000. So a 10% increase in sales from $250,000 to $275,000 results in a 50% increase in net operating income from $20,000 to $30,000. Okay, let's take a look at a quick check. Coffee Klatch is an espresso stand, same numbers as we had in the previous slides. An average selling price of $1.49, average variable expense of 36 cents, and an average fixed expense per month of $1,300. So an average of 2,100 cups are sold each month. What's the operating leverage? Okay, so what we're going to do is we're going to take our sales. And how did we get those sales? We took $1.49 times 2,100 here. And our variable expenses, you'll remember from the previous slides perhaps, that it was 0.756 was that percentage. So we can take that as a percentage and away we go as far as our variable expenses are here. So our contribution margin is $23.73. We back out our fixed expenses, and that gives us net operating income of $1,073. So again, we can take our contribution margin and divide it by our net operating income, and that gives us 2.21 operating leverage. Okay. So now, same situation. This time the sales increased 20%. So how much should net operating income increase? Well, we're going to take this 20% and multiply it by 2.21. And that's going to take us up to, I believe, 44.2 if I did that in my head properly. And I did. So the percentage increase in profit would be 44.2%. Okay. So we can verify that simply by taking the 2,100 cups and increase it by 20%, multiply by 1.2, and that gives us 2,520 cups. We multiply that through times the per unit variable and selling prices. We get a contribution margin of $2,848. We back out the $1,300 of fixed expenses, and that gives me a net operating income of $1,548. And if I multiply 1,073 times 1.442, I get 1,548. Okay. So now, calculating break-even points are very useful in using cost volume profit. Here, an equation and formula methods can be used to determine the unit level at break-even and the dollar level at break-even. And break-even is when we're going to have a target profit here, net operating income, of 0. So let's use the RBC information to complete the break-even analysis. So here, we were selling the 500 units, as shown here, but that's not break-even. So if I wanted to know break-even, I could do that by taking the contribution margin per unit times the quantity minus the fixed cost. That's going to give you your if we solve for fixed expenses here, that will give us our answer for that. So what we're going to do is we're going to take the $200, multiply, take 80,000 over here to the other side of the equation and multiply 200 times the quantity. And so that is going to be $80,000 fixed cost divided by the contribution margin per unit. A key formula to remember. Fixed cost divided by the contribution margin per unit. That's going to give you break-even point in units. Okay, key formula. I'll say it again. Fixed costs divided by the contribution margin per unit. Okay, so now the formula method is a shortcut to that. And that's exactly what I just said. It centers on the idea earlier that each unit that we sell provides a certain amount of contribution margin that goes towards covering fixed costs. So for each unit we sell, my contribution margin per unit is going to decrease the fixed costs. So here's my contribution margin per unit, and here's my $80,000 fixed cost, and that gives me my $400. Now, let's say we wanted to compute sales dollars instead, required to break even, and earn a target profit of 0, which would be break even. We have an equation for that as well. So let's look at that. The contribution, the equation here is the profit is equal to the contribution margin ratio times sales minus fixed costs. So in this case, the contribution margin ratio was 40%. And so if I multiply that through this equation, which they've broken down for us here, I can take sales then will be equal to $80,000, which is our fixed costs, divided by the contribution margin ratio. So it's slightly different than the break-even point for units. We divided the fixed costs by the contribution margin per unit for units. Here, to calculate sales, we divide the fixed costs by the contribution margin ratio, which in this case was 40%. So that would say that sales is going to be 200,000. Now, when we count, I'm going to go back. When we calculated the units, it was 400 units. We could also multiply that 400 units times the $500 selling price and get that same $200,000 in sales. Okay, so here they've broken that down nicely for you. They're taking the fixed costs divided by the contribution margin ratio to get the $200,000 break-even point in sales dollars. Okay, so Coffee Klatch, same scenario here. What's the break-even point in selling at sales dollars? So we would, so what we would do is we would calculate the contribution margin ratio. We know the fixed expenses of $1,300. So what we're going to do is we calculated that previously at 0.758. That's the contribution margin ratio. That's the difference between, that would be the difference between $1.49 and 36 cents divided by $1.49. All right, so once you know that, then you can divide the fixed cost by the contribution margin ratio, and that will give you the dollars that you need to sell in order to break even. Okay, that looks like a good place to stop this video. And when we return, we'll continue on with the Coffee Klatch example.